Welcome to In the Workshop. This is part 2 of a series where I'm assembling a Stuart 504 boiler for my friend Andrew. After fitting the heat insulation to the side panels of the Stuart 504 boiler, it is now ready for a steam test. There is a slight problem with the Methylated Spirit Burner, and the Stuart Models Water Gauge blowdown cock leaks very badly. Apart from that, it is very good and makes a lot of hot steam. I removed both of the side panels, and as there's nothing to hold the chimney casting in place, it's sat at the back in this clip. I normally fit heat insulation to these boilers using a lattice work of metal. The official name of this stuff is rat-proof chicken wire. In my opinion, it is miles better than superglue or silicone rubber for holding the ceramic insulation material against the side panels. This is another 504 boiler that I have. I featured it in a video, that's why I wrote on it. The safety valve fits in the front bush and the steam tap fits in the rear one. This boiler is a later model to the one I'm currently working on. You can see the comparison here. The vintage boiler that I'm working on does not have the cast-in lugs like the later model. Other than that, they are identical, more or less anyway. Before I start this job, I'm going to sort out some small 4BA dome head brass screws. Most of the ones I have are too long for this job, but I remembered that in the bottom of the box there are some short ones. This is a part roll of rat-proof chicken wire, and it's very nasty stuff to handle. It's very sharp indeed on the edges. And to make matters worse, it is in a very springy roll, so if you're using this stuff, be very careful. In this clip I'm measuring one of the side panels, and as you can see, it's 7 inches tall. I need to cut 2 pieces of rat-proof chicken wire exactly the same size as the side panels. And quite amazingly, after I've done this, I notice that the holes in the chicken wire align perfectly in the area where the bolts need to go through into the boiler. You don't have to do it this way, but I like to do jobs properly. This stuff holds the heat insulation perfectly in place, and talking of heat insulation, here I'm cutting some. You need to leave the heat insulation half an inch longer at the top so it curls round under the lip of the side panel, like this. After trimming the sharp edges with a pair of scissors, I also used the belt sander to smooth it out, so it's not so dangerous now. But if you're handling this stuff, do take care, it is very sharp indeed. Here you can see the heat insulation rat-proof chicken wire sandwich. To make it look right, it's really important that the heat insulation is exactly the same size as the side panel. I purposely cut this one wrong, and here I'm trimming it with the scissors before fitting the part to the boiler. As I mentioned earlier, the holes in the chicken wire line up perfectly with where the bolt holes are. So I push the scriber through first, then I put the first bolt in position. I did this for all 4 holes. And by doing it this way, it makes it a very simple job to screw the panels in place. I find it easier to do this with the boiler laid on its side, and here I'm doing exactly that. Here's a bit of a tip: do not tighten the machine screws until you've fitted them all. Here you can clearly see the effect once I put the boiler on its side. I do find this principle to be the best one I've ever used. There is of course an extra bonus that the ceramic can't be damaged because it's protected by the chicken wire. The rat-proof chicken wire. Here I'm showing the fitting of the second panel, a very simple job, and now the boiler's finished. I was still puzzled why I found a brand new drain cock in my box of old drain cock bits, and then I remembered. I will show you the problem shortly. This job is very important. I'm locking the top part of the safety valve to the bottom one so it cannot turn. The pressure is set to blow at 60 pounds per square inch. In this clip I'm filling the boiler using a plastic funnel, which turned out to not be a very good idea because after a while it fell over and now my leg is quite wet. Take 2, using the special funnel that I made ages ago by fitting a brass adapter which is threaded to screw into a hole in the top of a boiler, and this one generally doesn't work loose. Time now to fill the methylated spirit burner. And once again I'm using the same funnel, which fits perfectly in the filler hole of the burner's tank. It's a good idea not to overfill these, by the way, because if you fill it right to the top, when it gets hot, the methylated spirits will expand and pour out of the hole, and then you have a problem. The hole in question is the vent hole on the cap. Don't be fooled by this simple device. These twin methylated spirit burners really do give out a lot of heat. This is the older type with the larger tank. This methylated spirit burner hasn't been used for many years, and initially the methylated spirits is reluctant to run down the wicks inside the tube. Eventually, with the help of my small blowtorch, it suddenly bursts into life, and as you can see, this is quite a flame. That's why you need the heat insulation on the outside. That is also why I've placed the boiler on a steel plate, to protect the bench. I carefully slid the burner underneath the boiler, and when I test the temperature, I couldn't keep my hand there for very long. There really is a lot of heat coming out of this chimney. For this steam test, I overfilled the boiler, and as you can see, the water is right at the top of the gauge. In the centre of the gauge is an air bubble. That's why you have a blowdown valve to get rid of these. As soon as I touch the lever on the blowdown valve, everything starts to go wrong. It would only seal in one position. I remember what the problem was. I bought 2 of these from Stuart Models, and the first one leaked very badly. So I rang Stuart Models to mention the problem, and Andy was very apologetic and said yes, a bad batch has come in where the tapers don't match. Well, I already knew that because I tried lapping the other one, and I lapped it so much that the handle just about came through the hole. Normally for blowdown valves since that period I've used these. It's a 180-degree globe valve, and the thread is 3/16 by 40 threads per inch. I want to show you something interesting. When I open the steam valve, quite a lot of steam comes out of the pipe, and also quite a lot of water comes out of the pipe. Why is this? Because the pressure is still low. It also shows how the water content in wet steam is capable of lubricating the moving parts in a small steam toy. As the water gauge was full right to the top, I thought I would just drop some water out of it, and as you can see, it's quite difficult to reseal this drain cock. I never really did like this type of drain cock. Yes, they look good, but very few of them are actually steam tight. The ones on my triple expansion engine are because they have PTFE liners. But on those, the nuts work loose very easily, but luckily I don't have to use them. They're really only there for decorative purposes. Now the steam pressure is at working pressure of 60 pounds per square inch. Look at the steam. Yes, it's just steam, not water. Here's a previous clip at 15 pounds per square inch, which is mainly water. As the pressure rises, the temperature rises. This is very hot steam because it is also going back through the fire via the superheater. And now the Stuart safety valve is blowing off. I think I'll connect the steam line to an engine. This is a great little engine. It's a Cheddar Puffin. It's quite old and it runs beautifully in either direction. I really only keep this engine for jobs like this because it has a displacement lubricator built in and you can just connect it up. As you can see, I'm still struggling to seal the blowdown valve. I had to manipulate the arm to just one position where it stopped blowing. At this point, I removed the methylated spirit burner from the boiler and blew out the flame. And the engine continued to run. Here's a bit of slow motion. The steam pressure is starting to drop and as you can see, the steam is also getting wetter. Surprisingly, this wonderful little engine ran for quite a while without any trace of a fire under the boiler. These engines are fine for steamboats up to about 3 or even 4 feet long. I've had quite a few and they run very well indeed. Here you can see the advantage of having a superheater. I ran this boiler for quite a long time, and the gauge glass is still showing quarter full. In the third and final episode in this short series, I'm going to perform another steam test after I've fitted a proper blowdown valve, and I think this time I'll try a steam test on my Stuart triple expansion engine. I'll be delivering the boiler to my friend Andrew on Friday. That's it for now though. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.